Welcome back. How are you all? Hopefully everyone's doing good this September day. Hopefully last week all went okay for you. At this stage you should be starting to become a bit more comfortable with using the command line interface, seeing how the commands work alongside their optional arguments that will alter the expected output. Maybe you wanted to reverse sort the output according to a date stamp, or maybe you want an ls-l instead of just your standard ls to list your files. So in Linux, I introduced you to variables as well. Remember, you don't need to declare what type of variable is before you use it in Linux. Similarly, you don't need to declare what type of a file when you're saving files as well. So it doesn't necessarily matter what the file extension is when you're using Linux anyway. Another important section that we had a look at last week was the use of the different types of quotes, the use of the backslash, that escape character, your backticks, that, let's say when you want to return the output of today's date, you can use the backticks around the system date command, and also how you can use more than one command in any script or on the command line by using the double ampersand, meaning and, so do one and next, or else the double pipe, beside Z on my keyboard anyway. You have to find it on yours. Sometimes it's up under the escape character, so you'll just have, it depends on what your settings are. Have a root around and you'll find it anyway. Remember always that you can use the manual page as well. So you have your manual page, you have your help, HELP as well. So if you click on HELP on your file or in your command line, then it'll open up your help command as well. Okay, and of course the lovely Slack. You're all the one class, many of you at least are at early experience of this. So don't worry if you feel a bit overwhelmed from last week's notes. There was quite a bit in it just to get you up and running, so I can't go into the scripting until you get some of the basics and an understanding of them. And that's what we're going to continue with today. So if you do my notes, go through the Netacad, which these notes are in conjunction with that, as you'll see from the kind of the footer on a lot of the notes, that some of them are taken from the Netacad, and then I just add in the labs then that I have as well. So that just gives you a bit of practical experience in using the command line interface as well, and all of the commands that we've mentioned. So overview of an operating system. It's a low level program. That's what it is. It is a program that allows you to run other programs. So here, just a basic block diagram of a Unix system. You can see that you have all your application programs, whatever we are using, and then you have the shell. For us, we're going to be using the bash shell. You've got the Linux kernel then that separates the software from the hardware. Remember, I had the picture of the bridge. So that's your hardware in there. So the kernel is another program that's going to directly interact with the hardware on the computer. So the drivers for the CPU, your central processing unit, whether it's an Intel or an AMD. For your GPU, if you're into gaming or graphics, you might have a GPU as well. So the drivers for that, drivers for the keyboard, drivers for your Wi-Fi connection, and all the other hardware all live in the kernel. So the idea behind the kernel is to provide a separation layer to the rest of the operating system. So let's say if you're using a word processor, it doesn't need to know how to interact with the keyboard or with your screen, because the kernel will do all of that. That'll be part of its responsibility, its functionality. So if the kernel is an overall company, let's say a management company, then the shell, which is out here that we use, the shell is more like the individual manager then on duty, supervising the user access and the likes to individual areas, individual departments. So your kernel is the higher up level of it. So the shell then is the program that runs on top of the kernel and allows you to launch whatever programs that you're running. So whether it's your command line interface, which of course that's what we'll be using, or any other programs that you can use in the shell. So for this class, We're going to continue on with some more of the fundamentals of Linux, and we're going to start off with working with files. This is, as I said, a lot of these notes are done in conjunction with, so in this case it's in conjunction with chapter 8. So on our Linux Netacad, if you're making your way down there and completing those exams that will all together become part of your continuous assessment, you can make your way down as far as number 8, which kind of sits in line with this set of notes that's coming up. So in there, managing files and directories, and that's what we're going to spend most of today working with. Okay, so it's great for you. It's great for you as a class group that you've all got different experiences, coming from different backgrounds, coming from different perspectives, because all of that will really help each other out when you come into using Linux and using the bits and pieces I see on Slack. You know, you've been commenting on issues that you've had and commenting on helping each other out, which is great. I'm going to leave you as much as possible unless it's something that's relating to the notes or you couldn't get access to the Netacad exams, things like that. But in general, if it's something that maybe you can help each other out, I'll take a step back. So that's all good. You're doing brilliant on Slack as well. This class then we're going to cover basics of file management. You'll always need to know this if you're working with whatever operating system. So if you're working with Windows, if you're working with Linux, and or your whatever distribution of Linux that you are using, you'll need to have an understanding of how to use globbing. Globbing is your wildcard characters. You need to be able to copy files, move files, rename files, and remove files. So we'll start off with globbing, which is being able to use wildcard characters, where it's very useful. For example, is if you wanted to find, you've seen me actually using it with the star sign. So the star can represent, if I wanted to find any file that begins with temp, so whether it's temporary, temp1, temp files, temp September, you could put in the temp followed with a star, which just means any other characters that follow it. So glob characters, for some reason I just think the word glob is quite ugly, so I usually use the word wildcards. These have special meaning in the shell. So these are again special characters, like what you have with your $sign. It's a special character that's used in your shell. This time we have the most commonly used one is your star sign. We'll come to those anyway. So they allow us to search for patterns, to search for numbers, to search for letters, and so on. So you can, instead of manipulating a file, you can easily execute commands that will affect many files. So you can rewrite or check the contents of, and so on. Your asterisks, probably the most common one. You can see here, if I have an asterisk in there, there's my ls-l list of my files. Then I use touch. Remember, your touch command just basically sets up a file called September 1, September 1 results, September 2, September 3, and semantic details. Sets up those files, doesn't do anything else, just sets them as being placeholders. Now if I do an ls-l and I only want to see all files that begin with capital S, lowercase em, and any other character, there we see our results. So asterisk, quite easy to use. If you decided that, well, actually, I only want to find out how many of the files that we have called semester 1, semester 2, semester 3. So maybe it just has the word semester in it, or it might have the word results in it, or it might have the word details in it. You can be specific, more specific in your searches. One way is to use the question mark. So if I said I want to use search for SEM followed by 1, 2, 3, 4, 5, 6 characters only. No more, no less. Then I can use the question mark. So it searches, matches exactly one character, right? So if you want to say, I'm looking for files that have 3 characters in them, it'll be ls-l question, question, question. Okay, so they just represent exactly one character. Or we could decide we wanted to put in a range of characters. So I could decide that in here, brackets are used to match your single character representing a range. So I could say I want to list any files that begin with S, capital S, or capital D. And it doesn't matter, there's my star afterwards, means S, however many characters. So you can see semantic details, semester 1 results, and so on, September SCPT. So S followed by any number of characters, or D followed by any number of characters. And you can see there's desktop, documents, and downloads. That's how you can do that. Brackets can also be used for a range. I want to list any files that begin with S, T, U, V, W. And it will reply back with any of those that begin with capital S, T, U, V, W, and any amount of characters. The ranges are probably more often used in terms of numbers. So in the range of 0 to 9, which means I'm trying to find a numerical character. Right, so that is using your brackets when you're doing your wildcard searches. Listing it, your -D option says display the names of directories instead of their contents. So you can see, if I go back up just a level or two, this one wasn't the one I'm looking for. So in these, when you do a listing, this one here, when I just did an ls, list any files, which can be directories, that begin with capital S or capital D. It doesn't matter how many characters are after it. You can see here it says semantic details, there's files, and then for where it found a directory, it lists the contents inside that directory. What if I don't necessarily want to list the contents inside a directory? Then you can use the -D. So it'll just list a directory without telling me what's inside desktop, what's inside documents, and so on. The other one then is the not, your exclamation sign. I'm sure you've come across that in programming, so it's a bit small there. You have exclamation S, list all files that don't begin with an S. Okay, so that's your simple not sign. That should be easy enough to use as well. Moving along, we have, so that's all your globbing characters. Good idea to maybe jot down the different ones and a single line to explain them. Slack, a great resource. If you're finding cheat sheets, that's great. Sharing is caring, so you can pop them up on your Slack for others to use as well. I do have some in practical in labs as well. Keep an eye. Right, copying files. So we want to copy one file. I'm not deleting it or moving it, I'm copying it. To do that, you have the CP command, copying from the source into the destination. So it will overwrite any existing files. Be aware of that. Overwriting can be dangerous because it will replace what was there. So if I already had a directory called September and it had a list of all the students and the results and their names, addresses, phone numbers, whatever it might be, this would overwrite it and just create a new file that it'll contain the set whatever was inside the semester 1 results. Okay, I definitely use star commonly, alright, a lot of times. So copying all the contents of semester 1 results into September. So that's your copying. Alright, there is an option to put in a -v command. So it'll cause a copy command to produce an output if successful. Basically, if you want to see what's happening, it's a nice way to do that. So using it here, copy -v semester 2 to September. So you can see now, oh right, yeah, this is what's happening. It's after catching semester 1 and it's copying it across into the September folder directory. So when the destination is a directory, the resulting new file will have the same name as the old file, semester 2, semester 2. Okay, so verbose, the word verbose means containing more words than necessary. In other words, it's kind of an excess. So this is giving me a bit of an excessive output, but there's times that you might want to see what's happening. So it's a good use of that. Always be careful of overwriting data. The copy command, as I said, it will overwrite what's in the destination unless you tell it not to. Unless here, for example, you can have an interactive mode. This -I can be used in so many commands. It is an option that requires the user to answer yes or no for every copy. So obviously it could be tedious if you have a lot of copying on files, but if you want here copy, overwrite, September semester 1. If you want to ask the user, are you sure you want to add this? Are you sure you want to delete this? Are you sure you want to copy this? This particular output could be changed to any question that you wanted. So just using your echo command in a script. But anyway, we'll get to that. So in here, the default is just CP : and it tells overwrite, and it picks up whatever files that you've been using. So that will allow the interactive option. So -I is another one that will allow you to become more interactive with the user. A little bit more of a security feature, isn't it? Error checking, error avoidance. Okay. To copy directories then, so the overwriting is your -I, your interactive option. If you want to copy directories, you can see using the copy command, if it's a directory, it'll tell you can't copy directories. You can force it to copy by using the -R, the recursive option. So that command will have it copy files and directories. Again, be careful with number 1, overwriting, and also if you have a large directory that has a lot of subdirectories and subfiles in it, you could be copying a huge amount of material. So just be sure that you know what you're copying and being aware. If you're experimenting, maybe create your own little temp files. Temp, one of my favorite folders. Okay, so that's all related to your copying of files. We have moving or renaming files, which are pretty much using the same command. If you want to move a file, you want to delete the original and create a new file, don't you? Which is the same thing as renaming the file, right? So those two are going to use the same mv command. So to move a file, you use that mv command. The syntax is pretty much the same as what it is for your copy command. You have your source and your destination. So when a file is moved, the file is removed from the original location and placed in a new location, the same as what you've always done with any files or any piece of content. If you don't have the right permissions, it'll tell you so. Permission denied, error message will come up, and you're back into your chmod command if you need to change the file permissions before you're allowed to move it. Some additional options for moving is your -I, your interactive that we've mentioned, your -N, not to overwrite destinations. There's a good one to be aware of. And then the -V if you want to see what the output is. Okay, so any of those are handy ones. Again, man space CP, and you can see all the options that you've got there. So as well as moving files, you can remove them. We want to get rid of files. I have too many, I didn't need them, so I need to get rid of files. One thing to remember is we don't have, like on Windows, it sends it to the recycle bin. The recycle bin doesn't exist here. If you delete a file, you have deleted it. Okay, it's gone. Delete file using your RM, and be careful if you're deciding to use the likes of matching your wildcard characters into this. Remove all files that begin with capital S, lowercase em, and a star. It could catch a lot of them, right? Be sure that they are the ones that you want removed. Okay, so again, be careful with overwriting when you're moving files or copying files, and be careful of using the asterisks or your any of the wildcard characters when you're deleting files. Use the -I. It'll ask, are you sure you want to? Which is always good when you go into deleting files. In particular, when you're creating a system for an end user, you should always try and preempt issues, errors, mistakes that might come up, such as that. Deleting by accident. Are you sure? Oh, no, I'm not sure. N for no. Deleting files, we have deleting directories as well. So you can use the RM command to delete a directory. So when a user deletes a directory, all the files, all the subdirectories are deleted without any interactive question. So again, it is better to use the -I, the interactive, anytime you're using a remove. So anytime, are you sure? Okay. To delete a directory, you can use the -R. There's the -R optional argument. Optional argument because it's optional. You don't have to use any of these -I, -R. You could just have RM space TMP. It'll remove them. So in here, the -R will be recursive, because if you look in here, ls TMP, right? List out what's in the temp directory. The directory called tutorial. I know it's a directory because it's blue. So when you list it out, that contains tutorial. This is back from class 1 when you create these directories. RM -I, that means the interactive. I wanted to say, are you sure you want to? RM can't remove it, it's a directory. So with directories, you must include the -R, which is your recursive. So the recursive one means that it will delete the directory plus all the contents inside it. So there's your recursive option. So the -I then is your interactive, isn't it? Okay, so alongside that, you can complete your chapter 8, managing your files and directories. Oops. So there's your chapter for that. Again, if you're just experimenting with bits and pieces, feel free to use the Ubuntu operating system that you've got on the right hand side of your Netacad. That's perfectly fine to use as well, okay? And also we have, that's the course, your labs, okay? So when you're on your website, here we go. So inside your week 2, class 1, you have file manipulation. So in here, the objectives, chapter 8, there's your, to create a temporary file. It's just going to be a text file. You've got your wildcards, have a look at those, make sure you can understand what they're doing using your find command is a file search utility. That's a new one. A possible output when you add in the correct command. So what is the correct command? What have I obviously scribbled out there that will allow me to get that output? Copying, moving and removing, verbose, CP, MV. Using your tree structure, if you come across that, maybe I've shown you that. Using tree, you get to see what the file system hierarchy, remember that tree type look, so that will print out that. And using your RM. Check it's deleted. Has it? Why has or hasn't it? Copy your file into the assessment directory. And then we're going to come into input-output redirection next. Okay, so that is moving us into the next part, which is input-output redirection. This would of course be lost without it, because by default our output generally goes to our standard output, which is the screen, or the printer if you're printing, right? They're two of the most common ones, aren't they? So your standard output will go to where we expect the output to go, to the screen, or to, what if we want it to go to another file? What if we want the output to become the input of the next file, and so on. Your standard input, what do we use most of the time? Keyboard. We give an input, and you'll see these FD0s, FD1, FD2. I'll explain those in a second. And then you've got your errors. You've got, in general, for any program or any command, has to be an input into it, there is going to be an output, and there's also going to be the possibility of there being an error. So redirection operators are a basic but an essential part of working on your command line. So the Linux shell will read the command line input, usually from the keyboard, and write the output. Usually the standard is to the screen. So with our input redirection, it will allow commands to be read. It'll allow the commands to read the contents from a file instead of waiting for the keyboard, the user's input on the keyboard. Your output redirection, we could save the command output to a file. So instead of printing it to the screen, I could say, well, actually push that output into a file. I'm going to use it later. And similarly with your errors, maybe I don't want the users to see every error that's cropping up. I can get the errors to just disappear, or I can get them to be stored in a different file. Okay, so let's get going with input-output redirection. When would we want to do this? Any open file can be redirected. Your ls command could be redirected into a file called filelisting.txt if you wanted. Redirection simply means capturing the output from a file, from a command, from a program, from a script, or a code block within a script, and sending it as an input into another file, an input into a command, an input into a program or a script. Okay, it just means that we want it to go somewhere other than to the screen. Okay, I want it to do something. I'm not finished with it yet. It hasn't done all its jobs. So you might want to list all of the files in a directory and store it in a text file, like what I just said with your ls going into a text file. You might want a list of all your currently running processes, and you might want to search and filter for some specific command. Searching and filtering, if you can list all your currently running processes, but it will list everything. What if I'm only saying, well, is the word processor running? Is the calculator running? Is there virus checker running? I want to only search for that, so I can use what's called grep, and we'll come to that as well. So I can use grep to filter out and to only search for specific keywords, phrases, characters. And you mightn't want the user either. If we move along to that standard error, we mightn't want the user to see every single error. They don't need to see all of the errors come up on the screen. Are you sure you want to delete it? Oh, there's been no such file or directory. Well, then if there's no such file or directory, maybe create one. Maybe don't tell the user that. It's up to me as the system creator that I'm going to create the file if it doesn't exist already. So you might want the user to see every single error, and what we can do is we can send away those errors if they're not needed, if there's no benefit to anybody. We could send them to what's called a dev null file for deletion. So there's a specific dev null, we'll come to it, and it just magics away all the errors. So all of these errors, file doesn't exist, name doesn't exist. If there's loads of these errors that you're coming across in your system, you're saying, do you know what, the end user will go bonkers if they have to read all of these errors. There's no real need for them. That in the background, what I should be doing is sending off those errors and creating the new user, creating the new file if it doesn't exist, and so on. So what we'll do is we'll run through each of those in turn. We're going to run through each of these little sections: your standard input, your standard output, and your standard error. Okay, and I'm going to show you how you can redirect either the standard input. So instead of we did a word count, I think, and we redirected our standard input using the greater sign. Or we can send our standard output to somewhere other than the screen, or we can send our errors. So there's 3 different sections, and we'll go through each of those. Before I can do it, I need to just explain a little bit about this FD0, FD1, FD2, which are called file descriptors. So by default on Linux systems, these file descriptors, this FD0, FD1, FD2, are reserved spaces, and they're only reserved. FD0 is reserved for the standard input, file descriptor 0, file descriptor 1 is for the standard output, and file descriptor 2, you guessed it, is for the standard error. So your kernel, as we know, that is our interface between the hardware devices, your screen, your mouse, your keyboard, and so on. It means that our kernel is able to understand that we want to transfer some files from our USB key onto the C drive, or that we might want to create a new video on my C drive or wherever it might be. As a consequence then, the kernel is permanently moving data from input devices, from the keyboard, for example, to output devices, our screen, our hard drive, and so on. Linux processes are essentially a way to manipulate, to change these inputs, and we can render various outputs. So we're going to change the read operation. Instead of reading from my standard input, my keyboard, I wanted to read from a file. I wanted to read from someplace else. And I want to write it to, not to the screen for a change, I wanted to write it to somewhere else. I wanted to write it to another script. I want to write it to CD, hard drive, whatever. So in here, a process in Linux, you've got Linux processes, and that means any active or running instance of a program. So when you start up any programs, they become active, they become processes. So you've got all of these file descriptors then that will contain more detail about these processes. A program is any executable file that's held in storage in our machine. Our Linux operating system is a program, it's an executable file. Our calculator is an executable file held on our machine. So anytime that I run a process or a program, I create a process. So a process is an active state. It's the running instance. Yeah, I've loads of software on the machine I'm sitting at the moment, but I'm not running all of them, so there aren't active processes. So processes know where data should be sent by their file descriptors. Okay, so it understands where the data should go to because we're using the file descriptors. Okay, so in there, your processes will know all of these file descriptors hold the information that's going to help our operating system to work with these processes. So in Linux, I said before, everything is a file. Your directories are files. It doesn't matter what the file extension is, they're all stored as files. So a file descriptor is a number. That's all it is. It's only a number on the operating system, and the operating system assigns it to an open file to keep track of it. So it passes out little post-it notes. You're number 1, you're number 2, you're number 3. Right? So it gives a little number to all of the active processes that are currently running on your machine. So in Unix, everything is a file. Regular files, directories, devices, they're all files, and every open file, every file that's running gets assigned a file descriptor. There's your little post notes. You're number 1, you're number 2, you're number 3. So your screen has a file descriptor, which is your standard output, isn't it, that I said was file descriptor 1. Your keyboard has a file descriptor, which I said was file, where's my starting point there? There's your file descriptor 0 for my keyboard, my standard input, my standard output, and my standard error. So they've all got file descriptors. Where am I? Here. So your file descriptors for standard in is 0, standard out is 1, and standard error is 2. Each of those. It's default that on Linux systems, for every process, the first 3 are reserved for your standard input, your 0, your standard output, which is 1, and your standard error is 2. And those file descriptors are mapped to devices on your Linux system. So my keyboard is mapped to 0. My screen is mapped to 1. The errors are mapped to 2. When a program is executing, the output, so it runs its whatever commands that it has, the output is sent to the file descriptor of the screen. Do you remember which one it was? Yes, file descriptor 1. And you see it on your monitor, you see it on your screen. If the output is sent to the file descriptor of the printer, the program would have been printed. So that's how it knows where it's going, where to divert the contents to. Okay, so you'll see it on your screen usually. Otherwise, if it has a different file descriptor which is reserved for your printer, then it will send it to the printer. So the output goes to the printer instead of to my screen. There's what they are. There are your default Linux system file descriptors for standard input, standard output, and standard error. Okay, they're the three important ones for now. Look at the file descriptors of any given process. So devices are registered when the kernel was started up. Okay, so once we opened up the operating system, devices got registered. So if you look at that, if you scroll along, if you go into that ls -l, let me open up my terminal window here. All of these are opened in your terminal window, in my terminal window. So I want to list out a long listing of the directory called dev, which stands for my devices. If I do that, it's just gonna fly down through it, and oh my goodness, so many, I can't see them. Remember, if I just use my up arrow, I can pipe it into less, and it allows me to just go down through it. There's my starting point. There's my CD-ROM. You can see that there. You can go down, see how your standard output, standard input, standard error should have their default file descriptors there as well. So look at loads of them in there, right? So they are all your file descriptors then. Back on into that. Time to. This is where I get distracted looking at them. Cute quit. Right, that's your device. There is some place in there where you should see your standard error, like what it is on the background in the screen. Your standard error going to file descriptor 2, your standard input file descriptor 0, and your standard output of file descriptor 1. So you should see those as your defaults, which are exactly as we said at the start, at the top of the class. So let's do something with them. The shell and many Unix commands take their input from the standard input. They expect them to come from the keyboard, and they write the output to the standard output, which is usually our monitor. And errors get written to the standard error. So by default, your standard input is connected to your terminal window, the output, and errors to the screen. So the error will usually come to the screen as well. These paths are called streams, and what we can do is we can alter, we can readjust these input output locations. So we can cause the computer to get information, get standard input from somewhere else other than the expected keyboard. We can send the results somewhere else other than the expected monitor or printer, and this is what's called redirection. So in there, there's your usual expectations. Our standard input goes into the program, and our standard output and error go to the screen. So input output redirection allows for command line information to be passed into different streams. So redirecting the input output is accomplished by specifying the destination on the command line using your redirection meta character. So these are your defaults, and what we have then is we can change where these are coming from. Don't want it to come from the screen anymore. Don't want it to go to the printer or the monitor anymore. And now we can change them. So there's your three streams and their defaults. Three files are open when you execute any program. There they are. So the basic workflow of Linux is take an input, create an output. Each Linux command has a single input, standard input, and two output sources, your standard output on your screen or your standard error. So unless you specify otherwise, as I said, your input's your screen, your output and error, your input is your keyboard, your error, output and error are your screen. So for example, if you wanted to list some file, you'll get an error. So in here, my standard, back into here, if I went into ls fake file, I want to list the contents of fake file, there's my output. By default, the output comes to the screen. The input, I've just sent it, was from the keyboard where it takes in the ls-l. So a file description then is associated with each of these files, and the numbers are important, especially when you want to redirect to some other locations. So redirection is just sending them somewhere else or taking it from, if it's coming from an input. The redirection characters are here. The shell meta characters, it will understand that if I see this less than sign, it's probably related to the standard input. If I see the greater than sign, it's probably a redirection of the standard output. If I see this 2 or 2 and a greater than sign, remember your standard error, your file description was 2, so it'll redirect that. And then your pipe character, if you want that to become the input of another file or command. So they've all got special meanings within the shell. They'll provide information about it. So they can be used to group command together, to abbreviate file names, to redirect. In these cases, these meta characters will allow us to redirect the input, the output, the errors, or to redirect and pipe. We can pipe our input and output, and let's go through them and have a little look. So your standard input in here, I'm going to say nope, I don't want it. I want to change this. I don't want it to come from the keyboard anymore. So this input, we use this less than character to receive the input from someplace else. Where is the someplace else? Probably a file that you've got. So the input redirector will pull data in a stream from a given source. So usually programs receive their input from the keyboard, but we can decide, actually, I want it from a different source. I want it from a file. So if I have a file called employee.txt and I want to sort it in alphabetical order or per time stamp, whatever it might be, then I can say, I can use my command in that way. So in here you have your examples. It's either using the less than sign or else the 0, because that's the file descriptor, and the less than sign. So it's your command, but instead of ls, or instead of, what did I mention there, cat. If I wanted to view the contents of a file, if I just do cat, nothing happens. So that needs an input. I want to view the contents of a file name. So there, take the input from a file, right? So in there's your cat employee file. Whereas if you want to sort it, maybe in this case there's cat, that'll work fine anyway. Whereas with your sort, you want to sort out, sort what? Sort out and take the input instead of being the keyboard. So I'm not going to write in sort Mary, Carolyn, Roseanne, Frank. I could do it manually on the command line, but instead of taking it in from me on the keyboard, I'm going to sort it according to the file. So I'm going to say, this is a new file. This is the file I want you to take the input from. So don't take it from, don't wait for the standard input, take it from this file. Okay, and then you can see that just sorts it, but it hasn't adjusted, it hasn't changed the file. So with this syntax, the contents of the file is redirected into the input. So the contents of the employee is redirected. You can see there I've used the star as well. Pure laziness, isn't it? Because I know I've only one file called employee. So the employee text is sorted out, it's put back out onto the screen, but I didn't do anything. I didn't redirect this output into another file to say sorted list or anything like that. So it just took the input and spat it back out into the standard output. So here, I don't see any changes. My file hasn't been altered because it's just taken the input, didn't do any changes, any redirections of the standard output. It assumed the output is the screen. So just as the output of a command can be redirected into a file, so can the input of a command be redirected from a file. Your greater than character then is going to be used as output redirection. So there's your, let's say here, sorry, I'll just finish, this is still on input. We're going to count the number of lines in the file. So this word count If you go into your man for word count, you'll see that the -L tells me just to read the number of lines. So I can find out how many lines are in a program, how many lines are in a script, how many lines of output are from some particular command. So use stats as the file, use that as the input into word count. Okay, so again, it's just redirecting that. For the standard output then, very similar. It's assuming the standard output is going to be to my screen. I don't want it. I've decided, you know what? I don't want it output to the terminal. I'm going to cut that out and I'm going to do something else with it, right? So our output redirector is probably one of the most recognized characters used an awful lot. So if you have an echo, there's echo with my name. I decide, well, actually, do you know what? I'm going to do something with, if this is a command or if it's a piece of code, or maybe it's the next in a list of a database that I'm creating, I can get it to redirect. Instead of just printing it on screen, I'm going to get it to redirect the output into a file called class list, right? So there's, try it out. So the standard output is usually our screen, but by default our echo function will just put it out on the screen. If I want to amend that, I can use the forward the greater than, isn't it? Yeah, greater than sign. The main problem, there's always a problem. The main problem with this is this redirection will overwrite if class list.txt contains 200 students that are about to graduate, and I do echo Caroline Cal output redirect into class list, it will be all overwritten, wiped out, and now the file will only contain Caroline Cal. So oftentimes if you're using redirection, if you want to use this redirection overwriting file, it would be a good idea to make sure that if you're using that, you ask the user, are you sure you want to overwrite the class list file that already exists? Okay, but we have an easier way. So that will overwrite if the file already existed. Again, we're back in, we're still using our standard output. It overwrites it. So that is the problem. It overwrites any existing data that's already sitting there in the file. So if I did hostname into class list and you had a look at that, practice, go on to your command line and do that, it will have overwritten the file. So instead of that, what can be used is your redirection of standard output using a double greater than sign, and this stands for append. So the single will overwrite the contents of the existing file, but this one is so much safer. If you want to add in a new record or something, or add in a new piece of content into a file, this is what you would do. This allows you to redirect the output from your commands, but instead of overwriting, it will append. So there is date into class list. So if I have a look, there's date, it overwrites class list. So if I add Caroline Cal or your name or whatever, it's been overwritten. Okay. If I add in host name and I append it, look at the appending, it will keep what was existing in the class list file, keeps that in it, and now it will also add on the host name. Okay, there's the username. Again, you might want to put in the username into the class list. There's a third new line, echo few each line, and I'm appending it again using my double greater than signs, and you can see we've now got a fourth line. It doesn't overwrite it, it appends, it adds it on to the end. So a much safer character, as you can imagine. The alarm bells won't be going off in your head. Finally, we have redirection of your standard error. Okay, this one is very commonly used. Do you know what? They all are, but this one, because if you're creating a system for an end user, they don't need to be bothered, they're Barney, with reading every single error that comes up. So if you want to create a new file, or you want to append content into a file, it doesn't need to tell me that the file doesn't exist. Get your script to create this file. If I want to execute a program, I don't want to see that, oh, I don't have permission. Get your script to change the chmod to allow the 755 on it. Okay, so in there you are redirecting errors. So if you don't catch them in your script, you don't want them printed out either. Usually, a lot of times anyway. So we're changing this from the error file descriptor going to the terminal window. I'm going to say no, I don't want it to go to the terminal window. This particular end user does not want to see all of the errors. So here is your file descriptor 2 being redirected someplace. So the standard output displays the expected results if the errors appear. They are usually going to go to the screen, like the output here. I could have list the contents of fake, no such file or directory. But why not just have it returning back with my command line, my command prompt? So when you want a program or a script, if it doesn't generate the expected results, it'll throw back an error. The errors usually goes to the standard output, which is our screen, but it can be redirected. The standard error operator is this 2, because that's the file descriptor 2. For any of the other ones, you could use 1 and your append, or 1 and your greater signs. This time around, we're saying it's 2, because this is standard error. It is not for the contents. And here you can see the difference. So ls fake, if there's an error, send it to error.txt, and then error.txt will contain the error. If that's assuming you want to store the errors. Do you want to store? Most time probably not. So this is if you wanted to store the errors in a file. So maybe you have errors.txt, you want to store contents in that. So there's your 2, your standard error for a file descriptor. Redirecting, I'll come to that dev null in a second, where you don't always want to store your errors. Redirecting multiple streams. Looking at this, I can see a bit, what is all of that? Take it in parts. There's a redirection of my standard error, and there's 1. Which one was 1? It was the standard output. So your file descriptor was your standard output. If I remember your file descriptors from even the page beforehand, file descriptor 1 is my standard output. So in here I can join them together. I can run more than one command. So I'm saying redirect my errors to the same place as my standard output, wherever that's gone. So I can list the contents of my user bin, which contains my binary files, redirect it, overwrite, that's that one, into a file called command.txt, and send the output. Any errors will go to the same place as my standard output. So this 2 greater than sign ampersand 1 will merge the standard error with the standard output. So this construct allows for both the standard output, file descriptor 1, and the standard error output, file descriptor 2, to be redirected to the same command.txt. So both your standard output and your standard error can be sent to a file. A cleaner way that is most often used is this ampersand /. So you can see all of this gets replaced with, if I pull it back over here, you just have the ampersand /. So the ampersand /, this one here, this redirection operator is actually just a shorter version of this 2 greater than ampersand 1. It's this shorter version. You can see up on top now, that'll make a bit more sense. So these are the same thing, okay, just a shorter version that all Linux distributions will understand as standard. So it's a shorter version of this. So it'll redirect both your standard output and your standard error to the file called command.txt. So any output that there might be, listing those, or any errors that there might be, they'll all go into this command.txt. Okay, so it catches both the standard error output, there's your 2, and your 1, your standard output, and it'll redirect them all, overwriting them into command.txt. Some examples there. List the contents of 2 directories, documents and ABC. So the first one, ABC, didn't exist, and documents did. I don't need to see that, so I'm going to redirect the standard output, the error, or I'm going to redirect the documents part. So list out documents and ABC, but if there's any errors, then send them into a dir list. Or your output, the output, the standard output, will be redirected into dir list. So now it's just the error. And this is where this comes into play. Your 2 greater than ampersand 1, which can be just replaced, more streamlined, as the ampersand greater than. Okay, that's an easier way, a shorter way, a faster way for you to remember it. Right, again, have a little look. So both standard output and standard error can be sent to a file using that. So it's possible to redirect the output and the standard error at the same time. If you want them to go to different files, you can. They can be redirected using both your redirection, your standard redirection, just your greater than sign. That would be the general way of redirecting your standard output. If you were to go back up, redirecting your standard output is just the arrow. If you only want to redirect the standard output to a file and you want your errors to go in someplace else, you can do them separately. So you can do both of them at different times if needs be. So if you want your standard output to go to a different file, list, fake, and the etc ppp. Put the output into example.1, but if there's an error, send that to error.txt. So you can use more than one command in one line of code. This I mentioned if you have errors, you don't really want to store them. I'm not going to go and check in errors, because if there's an error, so be it. Send it away. I don't want it to come up saying there was no such file or directory. So if I was listing something, it didn't exist, just drop me back into the command line without giving me all of this extra content and another line of code on it. So in all Unix-like operating systems, this dev null, which is also known as a bit bucket, is for when you have the situation where you want to redirect your output of your command, but also you want to throw away any errors. So you can do this by redirecting the command's output into the bit bucket, into this null file. So it consumes all output sent. It's like a black hole. It all disappears. So in there, if you were listing a file, instead of me seeing that, can't access, no such file or directory, I just want to get back to my command prompt so I can continue on. If the contents aren't there, just bring it back to the command. If the contents are there, list them out. But otherwise, just bring me back to my command. I don't need to be seeing that there is no such file or directory. That's where you can use this dev null, this bit bucket to use. Remember, it's like a magic wand. It disappears. Your error isn't stored anywhere. Generally, you don't need to store errors. You just want them to magically disappear. Okay, so that's what this bit bucket is for. It just gets rid of it. So let's say you are making a new directory. If you did a make dir and the directory was already there, okay, let me just see what I have here. So here's my example of where I could use a less, just to have a quick look and see what I have on it. Oh, and here's an example. Oh, can't be installed. I thought I was going to have to press Control C now. So all of these, if you have files, if you have directories, or if you have listings, Q will quit that. ls -l right? I can see directories here. When I go into my ls-l, this first one is the directory. It tells me if it's a directory or blank for a file. You have the user, read, write, execute. You have the group, read, write, execute. Write is turned off, so it's going to be represented by 101, and that's number 5. And you have read, no write, and execute there as well. So any of those with a D, you can see they are directories. Okay, so as you go down through any of these ls-ls, you become more familiar. So there's my directory called computer systems, all in lowercase, right? So I'm going to click on Q to quit. If I want to create a make dir computer systems, make dir computer systems, it tells me the file exists. I don't really need to know that. If it's existing, that's great. I'll still work away on it. This is where you can send it into its Bitbucket. So I can say, well, if there's an error, oh, wrong one. If there's an error, send it into my device and my null, right? So it just returns back to my command prompt, and off I go with my whatever commands I might be doing. Okay, so you can put in your echoes and whatever content that you have on it. It'll just return those. So not always do you need to store these errors. This isn't going to be any benefit to anybody. If it exists, great. That means I have it in the background. If it doesn't exist, well, don't tell me. Once I know it exists, that's all I'm worried about. So that is your Bitbucket when you want an error to poof the magic dragon and magically go away. Redirection to devices. Again, it is your standard output. Nearly done. We can redirect your standard output to the screen, to somewhere other than the screen, I should say. But not only to files, you can send it to devices. Okay, if you want to see what devices are connected onto your machine, you can go into the DEV standing for devices and see what's there. So maybe I want to see, cache this, read that file and put it into my dev audio file. Okay, so the cat command reads the file, sends the output to the dev audio, which is my audio device. I mentioned your cheat sheets and that there'll be bits and pieces thrown around in the notes as well. So print them out if you want to, so you can see these redirections. You will definitely be using those as you go down through creating shell scripts and creating your shell assignments. Your redirection here, week 2, there's your standard output. Give them a go. Okay, it is brilliant even for a little bit of experience to get to understand how sensitive that Linux is in terms of capitals and spaces and these meta characters that have special meanings in them. So in here, have a look at these redirecting. So this one is appending a new record into your employee.txt file, redirecting your error, redirecting your output and your error, and then you've got, oh yeah, that's today's class. Yeah, so the input output redirection. So the lab for that will bring you through some examples of all of those alongside module 8. So if you can get up to and including 8 for the moment, and hopefully you're all doing okay. Takes a bit of time to get through it, but you know what, you'll be flying it pros in no time. Right, thanks everyone, chat to you later.